What's up, YouTube? Alright, so this is going to be an update to my solar water heating system. Today is New Year's Eve, December 31st. New Year's Eve. So the past week or so, it's been super cold and we've had no sun. And then just today, the sun came out. And the temperature right now is -3 and the real feel is -24. So this is going to be a great test just to see how it works because I've only had it working once since I changed out that pump. So I am going to run outside real quick while we still have sun, and then I'll come back in and we'll take some temperature readings and all that. And right now it's at 1:45. Alright, so let me bundle up real quick and we'll run outside. Alright, so this is the south side of my house. I have 4 of these 4x8 Novon solar water heater panels, and they've been doing pretty good. Of course, this part is not the DIY part, but it kind of is. But anyway, from inside the house, it comes out through some copper lines right here. Of course, I have this foam insulation over it. There's actually an in and an out 1/2 inch copper pipe right there, and there's a little tube on the left hand side, which is a 1/4 inch line. That is my vent. And I also have that black extension cord right there that also comes out of that hole. Probably not a great idea, but that's what I did whenever I did it. And the black extension cord, yeah, I know you can't really see it very well, but I can't quite get to it, but this snap switch, which turns the whole system on, is attached to one of the copper outlets / inlets to the next panel. They're connected by a 1-inch copper pipe, and I just attached the snap switch right to that copper pipe. So once the panels heat up, it'll turn on that snap switch, and then which in turn turns on the pump downstairs. The snap switch is underneath that insulation that's pretty much half gone already, and that's basically what turns on the whole system to get the first pump to start circulating. Once the panels heat up, it'll turn on that switch. The switch then turns on the pump. It'll start recirculating, and then actually like a minute later it'll shut off because the cold water was introduced into the system, and then once those heat up, it'll stay on after that until the sun goes down, or the timer will shut it off. But anyway, it comes out of the house and comes over to the lower end of the panel over here, and then gets super hot and goes all the way up to the top through all 4 panels. And then on the far left hand upper corner, it exits the panels and then goes back down. Goes back down and then makes its way back into the house. And yeah, I got a little bit of extra crap down here too. The panels usually don't get too much sun until around 11:30 or 12 a.m. or p.m. for the 12 part. And that is because we have all these trees right here, and this is facing east, and that's kind of southeast, and there's some really tall ones out there, so that's usually why I don't get too much sun early. And then of course, since it's winter time, the sun's gonna set way back over there, so it'll go through that tree as well. Alright, so right after I got these panels and got it all hooked up, there was a hole. I don't know if you can see the kind of wrinkles down that center there. And of course, after I get it all hooked up, it started steaming right out of the center there, so I had to pull off the piece of glass. And on each one of these 1/4 inch lines going up and down, they have like a black, I don't know, thinner layer of copper on it, which is basically like a collector, which helps it collect more sun basically. Anyway, I had to cut out the bad piece, and I just sweated in another piece of 1/4 inch pipe, and it's been holding ever since, and that was probably, like I keep saying, about 7-8 years ago. Alright, so the brand on these are Novon, N-O-V-A-N, Optima 2. I know this isn't a very good picture, but it's on the side of the panel and I can't really get to it. If I can find an actual tag, I'll post a picture of it, but this is basically what it says. But that's basically it. That's what all 4 look like on the outside. Alright, so again, apologize for the light. There's just no light over here, so I have like a couple of lights just randomly placed so I can get a little bit of light. Alright, so this is basically a big tank. I don't know how many gallons it holds, maybe like 30 or so. I think I got this tank from my dad out in Wyoming. I don't remember exactly what it was for, but I do think it was some sort of circulating hot water or whatever type of system. And of course I wrapped it all up in insulation to try to keep as much heat in there as I possibly could. On the bottom I don't have any insulation underneath there just because this was just left over from I think whenever we did our bathroom remodel. I don't know. I just didn't go out and get more. So from outside it comes down through the little 1/2-inch copper pipes where it comes in and comes back out. And you can see the 1/4-inch line and the extension cord. But anyway, they come in through the house and then drop straight down. And of course this isn't going to be the very best video, but it'll give you an idea of how it all works. So anyway, it comes back down and there's a pipe right underneath here. Not this one, but the one right underneath it. That goes into the tank. And then it comes back out through this pump right here. The brand is called a March pump. It's a 12-volt pump. And basically all it does is recirculate everything that's in the tank back out to the panel. So of course it comes back out through this pipe here and goes right back out. I do also have a little spigot right here just to empty the tank if I need to do any sort of maintenance or clean it out or whatever. I'm probably gonna change this pump because, well, for one, it's 12 volt and I don't need it to be 12 volt anymore. It is a little noisy and it has a little bit of vibration to it, so I've got like random tape and extra foam randomly throughout these pipes up here just because it starts to vibrate and it's kind of loud and annoying. This pump, when I originally put this on, the original idea was a long time ago, back in like 2008-9 time frame. I was kind of into a lot of the prepping type stuff and I went with this 12 volt pump because it was a little more efficient. It was 12 volt and I had a 12 volt solar power system at that time, and of course the whole reason was to run it straight off the batteries, which I did at one point, but I don't have 12 volt anymore, so I have to use so for my workaround to get this pump to work, I'm actually using a computer power supply down here until I can replace that pump. And of course what turns it on is your black and green wires right here that go through a switch just in case I need to turn it off again. But this is the black extension cord which runs outside to the snap switch. So once that snap switch turns on or completes the circuit, it'll basically connect the black and green wires together, which will in turn turn on the pump. I don't have, of course, all of it completely covered in the insulation, but that's okay. It usually gets hot enough where this doesn't really matter. This is where I technically fill it up. I just pull this little coupling off here and then put a funnel, and then I just pour antifreeze into it. Antifreeze and water. And of course, since it does get so hot, I had to make it into a vent because it does get so hot. And I pretty much had to put this on here because it kind of creates a little bit of pressure to vent it outside and relieve some of the pressure. It will be steaming pretty much out of that pipe all day long. So I do have to kind of keep an eye on the level. I don't have like a level set gauge or anything like that for how much fluid is actually in the tank. I usually just go to the other side and kind of lift up on a little bit, and based on the weight I know when to add more. I have another pump right down here. Alright, this is the taco pump. I like to call it taco since I can't pronounce anything. I swear I did graduate high school, but that was it. But it's probably taco. Alright, so this is the taco pump that I did replace. I actually had it facing with the motor part down, and you know, it leaked and filled up the entire thing, which made it short out or whatever. But anyway, once the tank heats up, roughly 125 or so degrees, this pump will turn on and pull it from this side of the tank through the pump, and then it goes up a little bit to the ceiling down here, and that circulates over to my hot water heater and then goes through a little system which I'll show you here in a few minutes, and then it comes back to the tank, and that's all that does is circulate the water from the tank over to the hot water heater and then back to here. Alright, and basically how this one works, it's also based off of a snap switch, which is right over here. And this snap switch is technically from a fireplace like those blowers that you can put inside of a fireplace. And you can adjust this from roughly 90 degrees Fahrenheit up to 130 degrees Fahrenheit. And I have it set roughly to 125 degrees Fahrenheit. So once the tank heats up, it will close this circuit and then therefore turn on the lower taco pump. Alright, so this mess of wires and crap right here is kind of what regulates the entire system. Alright, so this timer switch here, I have the computer power supply plugged into it. The only reason I have that is I want the pump to shut off roughly, well, in the wintertime, usually around 4:30, because the sun is usually either over the house at that point and it's not on the panels anymore, or in the wintertime like it is now, it's already on its way down and in the trees. So I have this set on a timer to shut off the 12-volt March pump because I don't want the tank water to start getting cold. So if I shut that pump off, I can retain some of the heat inside of this tank to circulate over to my hot water heater. So the power supply will turn on roughly 8:30, 9 o'clock in the morning, and all we're waiting on is the sun to heat up the panels, to close the snap switch to turn on that 12-volt March pump. This one right here is the taco pump, and that one kind of regulates itself based off of the fireplace snap switch. If I remember right, those snap switches, there's only like a 5 or 10 degree difference in order for it to shut off. I could be wrong. It's been a long time since I hooked all this stuff up. But if I left it on 125, that means it'll shut off maybe around 115 or so degrees. And that'll work for me. This was set up a little bit different, but I just redid some of this stuff whenever I changed the pump, so this is a temporary thing for right now. Alright, so there is a couple of things I probably do need to improve, obviously, down on this system. I knew a little bit about electrolysis in, systems like this with the different metals and stuff. All I knew is that I needed to get roughly 6 inches or so to separate the tank from the pump, which this is the galvanized fittings right here, and then it has galvanized on the other side, which I went through another 6-inch piece of brass before I went to the copper. This side I probably should have put a piece of brass right before it goes into the tank, because the tank is made out of like steel. I don't know if it's lined with anything, I have no clue, but I think that was part of the reason why this pump went out, is because too much electrolysis happened in the system, and this pump, the impeller was full of that gunk, basically rust or elements that is pulled out of the system. So I probably technically need some sort of dielectric coupling down here just to separate the system a little bit better, which I'll probably do here sometime in the future. I just haven't done it yet. Alright, so I just turned off one of the lights so we can maybe check the temperature of the tank here. Of course, it's too bright to show up. Alright, so we're roughly 130, depending on where you hit the tank at. 137, 138 degrees. And keep in mind it's like negative 29 outside. Alright, so it's kind of hard to see on the screen there, but the pump side or the water inlet is roughly 140, well, it had a max of 144. Yeah, no, you can't really see that. Alright, so from here it goes out and goes up to the ceiling, and then it heads over to my hot water heater, which I'll show you right now. Alright, so this is looking up at the ceiling. We're over near my hot water heater. So it comes down from the ceiling, and then it cuts over. Then it goes down into this homemade DIY, it's called a sidearm heat exchanger, which I'll insert something into the screen to show you how it works. So it goes into the heat exchanger here, and it goes down to the very, very bottom, and then exits, and then goes right back the way it came, all the way over to the tank to recirculate. And I cut the tape on here just for this little video, but one of the things I did do whenever I changed the pump, trying to cut back on the electrolysis, I did put a dielectric union right here. And dielectric, all it means is it's basically an insulator from one piece of metal to the other piece of metal. The reason I'm trying to cut back on the electrolysis is since this is all copper pipe, the copper pipe that is attached to my hot water heater is also attached to the ground in my electrical panel, which that's what they did back in the day. I don't think they technically do that anymore. I think they actually run the ground from your electrical panel to an outside ground rod, which I will do as well as soon as the ground thaws out. My temporary fix to help it along is I installed a dielectric union here, and I also installed one down here at the bottom. Another thing that you can use this for is technically like a clean out. If for some reason there is some sort of electrolysis or any sort of debris in the system, of course it's going to settle down here at the bottom, and I could technically unhook the unions and flush the sidearm heat exchanger out, but I didn't really need to do that this last time because I installed a little tiny it's like a little T-valve, a little needle valve that you would use for your refrigerator line or something like that. I installed one of those there so I could just pull this little insulation off and turn the little T, and I can kind of drain the system right there as well, which is kind of like a little mini clean out. Alright, so this is part of the homemade DIY sidearm heat exchanger thing. This is the cold water in, which brings the cold water into your tank and takes it all the way down to the bottom of the water heater. Well, what I did is, of course, I tapped into it with a T right here. So the hot water from the sidearm heat exchanger is super hot in here, so it forces the water up and into this. Technically, yeah, it could try to go back up into the system, but it's not going to. It's going to go down into the water heater tank. And what it does is it creates a thermal siphon. Alright, so this is the lower side. This spot right here is where you would normally have like another hose to drain the tank, and I just tapped into it and then started the sidearm heat exchanger going straight up. I also extended the tube a little bit and put a little spigot here, so if I do need to drain the tank, I can still do that. There's a hose fitting right at the end of here, but of course I just wrapped all of this to try to keep in as much heat as possible. But anyway, the theory of how all this works is it's going to heat the inner tube up, which has the water from the hot water tank. It's going to heat it up really hot, and therefore it has no other place to go except for up. And then it's going to pull the colder water or cooler water out of the bottom of the hot water heater tank, and then of course send it straight up to the top. And that first taco pump, that's its job, is just to circulate water to the sidearm heat exchanger, which keeps it really hot and therefore creates a thermal siphon, and all the water does just circulate all day, pretty much like that, all day long. Alright, so for the little thermostat, I usually keep it in the winter time, kind of close to, I guess, a normal operating temperature, and that's only because we don't obviously get as much sun in the wintertime, and it's only, you know, it's really only out there for a couple hours on the panels, if there's sun at all. In the summertime, I'll actually bring this way down here because we get a lot more sun in the summertime, and those panels and tank get super hot. So I don't know, it's probably not the very best system, I know that, but it does work. And alright, so it just kicked on. I don't know, it's 2 notches away from the hottest it can go, and it just kicked on. So it has gone up. I don't know how many degrees that actually is, but this is where I typically keep it in the wintertime. And if we have a projected like no sun, this temperature right here is usually okay. Alright, so here is, let's see, you probably can't see it, but there's a piece. I got a little extra stuff on there, but that's okay. This is where it comes from, the solar hot water heater tank, and it has a little 90-degree elbow on it, and it goes straight over to the hot water heater tank. Once it comes back in this line right here. And I have these 2 ball gate valves, or whatever you want to call them. In the summertime, I typically close this one here and open this one up, and this will return the hot water back to the tank just to get hot again and come back and circulate all day long, or circulate as long as we have the sun. Alright, so in the winter time I have another pump, and this is more of like a boost pump, I guess. In the winter time I will close this gate right here and open up this gate, so what it does is it won't go back to the return, it'll go this way through this pump. And I've got some PEX hooked up right here, which I ran all the way over into my kitchen, which is the north end of my house, the coldest part of my house, and I just kind of snaked it underneath all the kitchen floor tiling from underneath to heat up that, of course, in the wintertime. And of course, once this circulates for a couple hours, the kitchen floor gets nice and warm. And I can't really show you underneath there because I put some insulation underneath the flooring just to hold in as much heat as I possibly can. Hopefully by the end of this video I can get some temperatures of that as long as the sun is still out. So we'll see where it is when I'm at the end of the video. Alright, so once it comes back, it'll come back through this PEX line here, and it's on the other side of the closed valve, which will send it back to the tank, solar hot water heater tank. And of course, also with this little system, I have a light switch here which turns this pump on or off. Basically, you have a winter setting and a summer setting. I'll see if I can't get a temperature of this. Alright, so the highest we're running right now, roughly 100 and you can't even see that. Well, it says 134. And of course the motor down here on the bottom says roughly 157 or a max of 161 degrees. Alright, so that's basically the whole system. It just turns on and circulates water all day long. Alright, so that is roughly how the system works. I got a tank down there. I don't know what kind of tank it is. It's made out of steel. I don't know if it's lined, but I do think it was used for some sort of circulating water or something. And then it goes through the 12-volt March pump, which goes out to the panels and then gets super duper hot, comes back into the tank, and then just circulates all day long, or at least as long as the sun is out. And then if the tank does get hot enough, it'll go through the other snap switch, which will then turn on the taco pump. Taco pump will take it over to the hot water heater and go through the sidearm heat exchanger and then heat up the inner tube, which has the regular hot water heater water in it, and that creates a thermal siphon which will circulate the hot water heater tank water as long as the temperature is high enough. And then after the sidearm heat exchanger, it will go back to the tank in the summertime. In wintertime, like it is now, it goes through the second taco pump, which is kind of like a boost pump at this point, because the first taco pump will not, it just doesn't have enough power to circulate it from the tank all the way over to the kitchen. So there's probably almost 100 feet of PEX underneath my kitchen floor because it loops back and forth all over the place and then goes all the way back to the tank to recirculate again. I'll put a couple pictures of temperatures I took of random spots of the floor. The kitchen floor does take a little bit of time to heat up. Of course, it starts off super cold because that's the coldest part of my house. Right now it's probably around the 70 degree range, but the floor can get up to around 80 or 90 degrees, which I will show whenever it does do that. Now I know I said in the previous solar hot water heater teaser video that the water must get over 240 degrees because I burned out the pump and all that kind of stuff. I don't really know how hot it gets. All I know is it gets super hot. I had to put a vent on there because it was building up pressure, kind of like a car does. That's why you can get the water to be a little bit hotter. If water is under pressure, it can get higher than boiling temperature. I'm not saying that I boil water back there or anything, but it does create some ridiculous steam. So I had to put that vent on there to relieve some of the pressure. Because when I first started doing all this, I did not have a vent on it, and I started out with all PEX and the PVC stuff, and I blew the pipe out there. If I can find a picture, I'll put it in there. So then I changed it all over to copper and put a vent on it. And that sucker in the summertime steams like all day long. And I kind of have to keep an eye on the fluid level because it does get so hot and release a bunch of steam. And that's probably part of the reason why it gets so hot in the summertime, because if I don't pay attention to the water level and the water level's real low, obviously it's going to get even hotter. And that's probably why it gets so freaking hot, because I just didn't keep the water level up. Alright, so since it is like negative 29 degrees out and we haven't had any sun for like the last week and a half, I will say that since it's wintertime, there is other problems that you run into, and since I just kind of put the system back in use like 2 weeks ago, I drained the system and I didn't put enough antifreeze back into it. So today the pump did turn on, but the line that comes out of the top corner and goes down to circulate it back into the house, that line was frozen. I actually had to go out there and it took me about 20-30 minutes to thaw that line out. All I did was used a torch and a heat gun. It took about 15-20 minutes because I had to remove some of the foam insulation that I had on it and then heat it up. But if I have the antifreeze mix stronger, I won't have that problem. We haven't had a winter this cold in quite a long time, so I kind of thought I was good, but I wasn't. Alright, so basically that is the entire system there. Most of it is kind of DIY except for the panels themselves. I did make the sidearm heat exchanger, but I kind of went off somebody else's plans for that. The rest of the system I just kind of made up. And since it is a DIY made up on the go type of thing, there's all sorts of improvements that I could probably make, which I'm sure most of you guys will list them down below. And you should list them down below, because if there's something that I don't know, which is a lot, I learned that from you guys, and I learned it from all the comments that you guys do put in there. So if you do see something that could be a little bit better, please comment and put it down below. I would love to make it a little bit better of a system. I do plan on changing out that 12-volt March pump. Like I said, back in the day, I was kind of under the prepping mode, so I wanted a hot water system to work with a 12-volt system. I didn't have it going under the floor at that time. I just had it heating up the hot water heater, and it worked just fine. But I don't have a 12-volt system anymore. It's 48-volt, which I could probably find a 48-volt pump, but I don't really need to do that. I could probably just get another taco pump and put that in there, and it'll be nice and quiet, and it won't vibrate and make a lot of noise. Alright, that is basically all of it in a nutshell. I'll try to put pictures and all that kind of crap in there if I can. And if there's something else that you guys would like to see on this little system, let me know and I'll try to do another video on it. This one is kind of quick because I wasn't expecting the sun to be out, so I had to kind of rush into it. And then of course the line was frozen. You know, I'll just add another gallon or two of antifreeze and call it a day. Alright, so that's pretty much it. Don't forget to like, comment, and subscribe, and we'll see you on the next one. So this is gonna be a it'll and this the on the of course. I don't think they tickle. This is technically the spot right here, and of course my furnace just kicked on, and that, or whatever these things are called. And I have these two switches, which is full of, it's just because the all and then all and blue, I blew and the, but if I have, and I know better in general.